Okay, so we're going to start here with chapter 9. Again, we're looking at the first two sections. The title of the chapter is hypothesis testing with one example. And what we're really looking for the first two sections is we're going to look at a couple of different things. We're going to look at how we start the hypothesis testing, and that's by writing what we call hypotheses, where we write something called the null hypothesis and the alternative hypothesis. Then in our second section, it talks about how we might make errors. We have two types of errors that we may make depending on the decision that we come up with the data that we are presented. So the first section is titled the null and alternative hypotheses. All right, so there are 5 steps to setting up a hypothesis test. What we're really looking at right now is we're currently going to be focusing on number 1. And that's to set up 2 contradictory hypotheses. So again, those are called the null and alternative hypotheses. Now, then what we're going to do is we're going to talk about the errors. And the errors are kind of, after we have done everything, we've gone through step 5, what could have this caused, whether we made the correct decision or the incorrect decision based off the data we were given. So next, we're going to look at defining more what these hypotheses are called. And we have, again, the null hypothesis and the alternative hypothesis. What these basically do, they're completely opposite of each other. And we're going to show a chart in the next slide. You'll see kind of how they are exactly opposite of each other. If you look at it, the null hypothesis is a lot of times believed to be true until we can show that it's totally incorrect. And this could be, this is usually proven with the data that we're presented. And then we run it through testing. Then your alternative hypothesis, again, is the complete opposite. And that's a contradictory statement that you start with. All right, so here's that table that I was telling you about at this bottom here. This is something that's really important. So you really want to make sure that you have this table somewhere when you're doing your homework, your lab, when you're taking your exams. At home, you want to make sure that you are able to take this little table at the bottom. This will really help you formulate on how to write these. So what you do is, after you determine what your hypothesis actually is, then you'll have to eventually make the decision. And there's 2 options for a decision. There's what we say, we reject the null hypothesis. And then we also will say, we do not reject the null hypothesis. And those are right here. Reject the null, and then the opposite one would be we do not reject the null. Now I left the second one in. This one that I'm highlighting, I'll kind of outline it maybe. I'll just highlight it. This one that I'm highlighting right here, the decline to reject the null. I don't really use that one at all. I like to say do not reject the null. The decline to reject, I feel like that's 2 negations, and it really confuses the crud out of me when I start getting tongue-tied and so when I start talking really quickly. So what you see in green, that magenta pinkish color, that's truly what the 2 phrases that I use when I make our decision. Okay, I'll say that we reject the null hypothesis, or I will say I do not reject the null hypothesis. Okay, those are really our 2 options we're going to use. The reason why I put that one that's highlighted in yellow there is this did come from the text, but also if you were to go and research some things, like you want to Google some extra examples, those answers may say decline to reject the null. And so I want you to be able to see that phrase as well, knowing that that's the same thing as do not reject. But in our case, you're not going to see that phrase pop up hardly at all when I speak, other than from what I just said right now. And again, I just feel like it has, for some reason, 2 negations with decline and rejecting. And then I feel like that's 2 negatives equal a positive, and I start flipping my math brain around. Now that table at the bottom, and I'm going to start talking about, so I'm going to zoom in real shortly. You can see that you have the null hypothesis in one column and the alternative hypothesis in another column. All right, so let's look at this table a little closer. So you have your null hypotheses column here, and your alternative hypotheses column here. And so when you look at this, it says that the null hypothesis will have equal. If the null hypothesis has equal, then the alternative hypothesis will have not equal to. Okay, remember, they're completely contradictory. They're completely opposite. We don't really use, you'll see it in some texts. I like to use equal, and the alternative will be just not equal. But you can also say it's equal, or say, hey, it's greater than, because that's also an opposite, right? Or we could say equal, and we could say it's less than. But the majority of the time, what you're going to see is equal and not equal to. Okay, these are all things that you may see, but not quite often. Then you can see the null here, it's greater than or equal to, and the opposite of greater than or equal to is just strictly less than. That way it covers all your bases. Less than or equal to, the opposite of that would be more than, strictly greater than. Not equal to, but strictly greater than. So it covers all of your aspects. That's why you'll see equal and not equal to. So it's either equal, what's the opposite of equal? Not equal. All right, so let's look at our first example here. And this is not so much of a, I'll show you exactly what you would write, but let's look at the context here. So an example of a null hypothesis would say that there is no more than 30% of the registered voters in Santa Clara County voted in the primary election. That's the part that we're going to identify as our null. Then your null is actually P is less than or equal to 30. The opposite of no more than 30 is more than 30 of the registered voters in Santa Clara County voted in the primary election, which then we would say is P is greater than 30. Now there's two symbols that we're going to use quite frequently here when we talk about our null and our alternative hypothesis. We're going to be using P, as you see here, and P represents, mostly we're going to talk about percentages. Or proportions, right? So we have decimals here. We'll take and we'll put percentages into our decimal form. You'll also see mu. These are our averages or our mean. So these are the two types of variables that you will see for our hypothesis. And that's what they really represent. So if you go through and you're doing a problem and it talks about, hey, the mean of this is more than 5. Well, then you're going to be using mu for averages for your hypotheses. If it says something like 5%, then you're going to be using P for percentages. It's just more of a matching game to the context. What you will actually write to represent your null and alternative hypotheses is you'll write something like this. You'll say that your null hypothesis is P is less than 30, and then your alternative hypothesis, P is greater than 30. This is really what you will write. Rarely will you ever write it in words. What will happen is you'll write it like I have there, boxed in red. And then you may be asked in the next question, what does the null hypothesis mean in words? And that's what you would write, what we have right there, that first bullet. One of the things while you're writing, what I forgot to say earlier, is the different variations that you'll see when you go to Google and start searching things. For alternative hypothesis, you will also see, instead of an A like that, you will see a number 1. All right. So sometimes it might be written like this. I'll write it here in blue. Your null will be written like we have here. And the alternative, you'll see it written as a number 1. Okay, so this is another way that you may see it. And again, the big difference is this A to the 1. Notice how my A is like an old-fashioned A, right, with that sweet little curl at the top. I honestly don't know why I write it like that. It's like the only time I ever write that A, but it must have been something that I learned down the way and I just kept it. And I really think that one of the reasons is because if I just write a lowercase a, since I go so fast, it looks like a 0, or my lowercase a's turned into thetas, then I'm really all messed up. Now I'm not even talking about the same type of math. All right, so I'm going to go ahead and move on here to example 2. So example 2, let me stress this out really fast. I want to, when I first did this, it's on a PowerPoint. So when I click the PowerPoint, the answers move in. Well, when you change it to a PDF, no answers fly in. The answers are just there. So I'm going to read this example. So it says we want to test if college students take less than 5 years to graduate from college on the average. The null and the alternative hypotheses are. So you can see a couple of different things. We are talking about the null hypothesis and the alternative hypothesis, and we have some keywords. Okay, the keywords that you're looking for is, you can see that here in green, it says that it will take less than, oops, sorry, I want to make sure I get to my highlighter. It will take less than 5 years to graduate from college. And the other one is that it's on the average. An average represents mean, so that's why we have mu. Okay, so what I have here, all of this, what I have right there, that does represent your null and your alternative hypotheses. But you can see that mu is used and the number 5. Now it says less than 5, and you have to say, okay, well, either that null hypothesis is less than 5 or the alternative hypothesis is less than 5. Now, how do you figure out which one? Eventually, you'll just get good at it and know. But if we go back to our table that you guys did a couple slides ago, we have less than is under the alternative hypothesis column. So when we go back to that example, it says it wants to be less than 5. The less than is going to the alternative hypothesis. And then the opposite, which is greater than or equal to, that's going in the null hypothesis. See? And you can even see that on the previous example. If we could go back to the previous example, you look at it and you say, all right, well, look, I mean, they're the same thing, but it's greater than in the alternative, and it's less than or equal to in the null. Same thing. Greater than or more than in the alternative, and then less than or equal to in the null. The only one we haven't covered so far is the equal or not equal to. In this problem, you have basically 2 numbers that pop up, but you know that you can see that in our null and our alternative hypothesis, the 0.066 shows up. And you could probably say, okay, well, I could see that this really is these here. All right, so first off, you have to know that we moved it from a percentage to a decimal, right, to a proportion here. So you will see this from time to time, especially when we're really working with values. And let's start looking at some key things here. So the first thing is it says that about half of all students. So this is how many. This talks about how many people or how many students. Right? So half is 50%. That's what we're looking at there. It also says that a third of them pass. This is called our success. So our successes. So 33% of them pass of that half. The same article states that 6.6% of U.S. students take AP exams. So this is now, again, how many? And 4.4% of them pass. And this is our success. So we know that they're comparing and contrasting, right? Now we're looking at what is it asking for us? or from us. It says test the percentage of the U.S. students who take the advanced placement exams is more than 6.6%. So again, here, what is it asking for? This is who take. This is how many. So those are the numbers we're going to try to look at. All right, and the last statement really tells you exactly what you're going to be using. But now it gives you some more focus, depending on if you need standard deviation and some other things that go into finding out and making the decision. So it says to take, and it is more than, so here's your key word again, more than 6.6%. So because it is more than, we go back to our table, and our table says that our more than is our alternate hypothesis. So alternative hypothesis is your more than. So when I take and I show you guys here, our more than is 0.066. And then our opposite of that, which would be the null, would be less than or equal to 0.066. Okay, so section 2 is now we're going to, now it talks about outcomes of type 1 and type 2 errors. These are the errors that we may or may not make depending on what we decide in the end, our decision. Where the data has led us to. Have we decided to reject the null, or has it led us to decide not to reject? All right. So this kind of helps you see what the errors may actually represent. And so what we decided is that you can't reject the null or that you can't accept it. So cannot reject it means that you do not reject it, right? We can rewrite it as this is do not reject, so do not reject. And then cannot accept it, that just means that we reject. So if we do not reject the null and then it's actually true, then we've come out with the right outcome. If we decide not to reject the null, but then it's actually not true, then we have a type 2 error. Now on the other end, if we decide to reject it after running all the computations and it is actually true, we call that a type 1 error. If we decide to reject it and it actually is false, then we have a correct outcome. There's 4 possible outcomes here. These aren't things that you need to write down, but it does help you understand them a little bit better. Let me zoom out a little bit so you can see it. So the first outcome, again, I kind of just spoke on these, says the decision is that we do not reject the null, and then the null is actually true. So we made the correct decision. A type 1 error is decision is we reject the null, but then the null is actually true. So it's basically called rejecting a good null hypothesis. The third possible outcome is that we decide that we do not reject the null when in fact it is false, meaning that we have an incorrect as a type 2 error. This is called accepting a false null. Okay, and you can see those keywords, rejecting a good null and then accepting a false null right there. And the very last possible outcome is that we decide to reject the null and it actually is false. So it's okay to reject. We have a correct decision. No harm. We're absolutely correct. All right, so we're going to move into something else to identify the type 1, type 2 errors, or how we're going to classify them with some variables here. So the first one is we talk about using alpha and beta. Alpha is the probability of a type 1 error, and then beta is the probability of a type 2 error, as you can see. We also have something right here called the power of the test. So really what we're looking for is our alpha and beta. We really want the probabilities to be very small. So we really don't want to make any errors when we decide these things. So the closer the alpha and beta is to 0, the better we'll feel about our results to our test. Now, the power of the test, we want that number to be very high, because if we're taking 1 and subtracting beta and beta small, then we're good. We really want the power of the test to be as close to 1 as possible. That basically is telling us that we're going to be as accurate as we possibly can when we make this decision. All right, so for example 4, what we're looking at is we're going to look at a null hypothesis and seeing what the type 1 and type 2 error would look like if this was our null hypothesis. So if our null hypothesis is Frank's rock climbing equipment is safe, well, we definitely want to make sure we don't make the wrong error here, right? When I'm rock climbing, which I don't do quite often, if not at all, unless it's at Funworks or Boomers or something, I guess, right? Then I want to make sure that equipment is safe. I don't feel like falling, and big guys don't fall softly. Okay, that's not how that works. So a type 1 error says that Frank thinks that his rock climbing equipment may be safe, when in fact it really is safe. That's a great error to make, right? He's like, you know what? It's not safe enough. I'm going to bulk it up. Okay, that's all right. No big deal. Now I'm even more safe. A type 2 error says Frank thinks that his rock climbing equipment may be safe, when in fact it's not safe. That's the error I'm not really comfortable in Frank making. Now, your two probabilities. Alpha, again, is the probability that Frank thinks his rock climbing equipment may be safe, when in fact it really is. And B is the probability that Frank thinks his rock climbing equipment may be safe, when in fact it really is not safe. All right, that's just basically tying type 1 and type 2 with alpha and beta respectively. All right, so example 5. Example 5 is just another example of what we just looked at. It's a little more long, it's a longer context, and you'll see here, I'll highlight it for you. But you still get to look at the type 1 and type 2 errors along with beta and alpha. So this null hypothesis states that the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. Okay, so what does a type 1 error look like? The type 1 error says the emergency crew thinks that the victim is dead, when in fact the victim is alive. A type 2 error is the emergency crew does not know the victim is alive, when in fact the victim is dead. So you have your alpha, which is your probability of a type 1 error, and then your beta, which is a probability of a type 2 error. Our last example here, if I recall, oh, I'm sorry, I might have fibbed to you. We have 7 examples. That is my fault. I know it's not going to be too killer for you, but so example 6. Example 6 talks about a boy genetic lab. It claims to increase the likelihood that a pregnancy will result in a boy being born. If I knew that this would be guaranteed, maybe we'd have another kid on the way. But my goodness, no offense, you ladies, but the girls are definitely more difficult to raise than the boys. Holy cow! All right, so especially when my daughter's already putting makeup on at a young age and doing all this, she worries the crap out of me. I'm in for it. I'm in for it. So if you look at this, you have type 1 and type 2 errors. So here's our null hypothesis. It says it has no effect on gender outcome. Has no effect at all. So that's what we're going to state as our null hypothesis. So type 1 error, the results when a true hypothesis is rejected. So in the context of the scenario, we would state that we believe that the boy genetic lab influences gender outcome, when in fact it has no effect. A type 2 error is where we fail to reject a false null. So again, it says it's a boy genetic lab does not influence the gender outcome of a pregnancy, when in fact it does. So that kind of gives you a different twist on the context. And right here, it kind of helps you out. It says, this results when a true null hypothesis is rejected. This results when we fail to reject a false null hypothesis. Okay, and that's why our power of test, our 1 minus beta, we want that very close to 1, because beta needs to be very small. Beta is the one that really kicks our hiney if we make the type 2 error. because it says again, this results when we fail to reject a false null. It's erring on the side of caution if you reject a true null hypothesis. That's a little being cautious. But when you basically fail to reject something that is not true, now you're definitely in for it, because you're basically saying that that is possibly true when it's not even close. Okay, so type 2 error is what we really want to minimize here. Now, let's example. Our last example here says a certain experimental drug claims a cure rate of at least 75% for males with prostate cancer. Describe both the type 1 and type 2 errors in context, and which error is more serious. So a cancer patient believes the cure rate for the drug is less than 75% when it is actually is at least 75%. Type 2, a patient believes the experimental drug has at least a 75% cure rate when it has a cure rate less than 75%. And which one is more serious? Definitely a type 2 error. We failed to reject when we should have. So basically a sense of false hope, right? If you're a patient and you're told or thought that it's at least a 75% chance of success, but you might have all these side effects with it, you're like, you know what, 75%, that's a pretty good chance. I'm going to go with it. But in reality, it's a 10% chance. Man, would you be pretty upset if you went through a lot of side effects and it didn't cure and you found it was less than a 10% chance, right? So those are the two different types of errors that we can and can't make.